I am Badrinath Mohan Kumar, incubator of Human College of Engineering, and I am supported by Nidhi Prayas funding for my innovation GEM robot. Now I would like to give some updates regarding the innovation, what I have progressed. So I'll start with the process of GEM robot working. So this is the rough crystal what we have, and this is a rough, we call it as rough gemstone, and this rough stone will be cut into many slices. You could see here the slices. So these cut slices are made into small small tubular structures like this. So this is the thing which has been cut, and this can be cut into many different sizes and shapes as required by us. So this cut rough stone will be made into smaller pieces, and these smaller pieces are stuck into this doping sticks, what we call as doping sticks. This is made of iron, and I could see closer. This is the gemstone we have stuck using wax, using fire and wax, and this doping stick will be given into the doping holder, and that doping holder, the function of the doping holder is to hold this doping sticks, and it will be rubbing the entire doping sticks into the discs what we have here. I'll explain it what it is. So, and that doping sticks or the doping holder, it will be controlled by the motor operation. So first I'll let you know what is this disc is. Okay. So this disc is something, it forms the core part of the system. So entire faceting, polishing, everything will be done in this disc. As you could see, it has two parts in this. One is the smooth, one is for smooth faceting, another is for rough faceting. So what is faceting is something like each and every stone has different structures, and the structures, an example I could show you here. So the example what you could see here is gemstone, a round brilliant cut. So what this round brilliant cut will have is like, it will have some index like 96 index. You could see here, you could see in the picture, if you could zoom in. So these are the index part. So the what is the function of that motor is, it has to micro step the doping sticks to angles which has been chosen from 48 to 42, 42 to 36. So all this cut, it has to work properly, that motor. So based on the motor controlled operation, we will be receiving this structure. So not only this is the top portion, you can see even the bottom portion. So for doing this, we need a motor operation which we have 5 motors for operation. So all we have is 5 motors. In that we have brought only one motor for testing purpose, and this is a micro stepping stepper motor. And what we have done is like one motor we have brought, and this motor we are trying to perform the rotation operation, up and down operation, horizontal and vertical operation, and linear movement of the entire doping holder operation. Everything will be testing using this stepper motor, and once if it is working properly, we will be going for ordering another 4 motors which performs this different operations, and we will be integrating those programs for those stepper motors. So for initial testing purpose, we have brought only one, and we are working on the testing for rotation operation for this motor. So this is the microcontroller board what we have designed, and based on this we will be designing the driver circuit programming, and which can be controlled using the keypad. For normal testing we are using this, but the end product will have a enhanced version of the keypad. So this is a similar, what you say, it's like a basic setup for testing purpose alone. We are using this, not for other purpose. So this one, the major part, I'll come back to this. The major part is this ceramic disc, which is integrated disc. As we said, there are no separate discs for faceting, smooth faceting and rough faceting. What we have done is like, we have chosen 2 different materials of the disc, and these 2 materials, it has been cemented. As you could see, the white thing, it is a cementing part. So this cementing part is the one which holds both the disc in a sandwich manner. So this cementing, it takes long time, as it is very important because this disc will be rotating at high speeds using the induction motor. So if this cementing is not proper, the entire process will get collapsed. So what we have done is we have given it to an industry which is working on the cementing part. So we have this material, and this material is chosen by us, and it has been integrated using some industrial support. So this forms the core part of this faceting part. And these two discs, what we have here is for polishing. Both the discs are for polishing. Initially we brought this disc and we brought this also in order to test which material will have effective polishing kind of thing. So we have brought these two discs. In this disc, what we found is like we were not able to get the quality of polish as required. But in this material, or in this disc, what we have here, we got 90 to 95% of effectiveness in this disc. So we will be going with this disc in the product. So these are some mechanical supports which we will be integrating in the system, like couplers, flexible couplers. So these are the thing which will support the mechanical design of the system, where we have the motor assembly. As the motor assembly involves 5 motors, we are to design the structure of the motor holding assembly. So that will be done in the later part, and initial testing is will be done using this. So this is some rough stone. I would like to show you a smaller one. So this is something we achieved using manual rubbing It is yet to be polished. So by manual rubbing, we have got this structure of a brilliant round brilliant cut using this disc. So using the smooth faceting and the smooth and rough faceting. So this is the progress we have made in this gem robot innovation. So in further moving forward, we'll be working on the motor assembly, motor structure assembly, and the procurement of further motors once this testing is completed. So thank you.